Imagine a universe smaller than atoms, smaller than protons and neutrons, a place where the very fabric of reality is alive with movement and unpredictability. This is the realm of the quantum foam, a concept proposed by physicists to describe the turbulent, frothy nature of space and time at the tiniest scales. At distances a trillionth of a meter, space is no longer smooth or continuous, it quivers, bubbles, and fluctuates in ways that challenge our everyday understanding of physics. Here, the concepts of distance, time, and even geometry blur into uncertainty, and the vacuum of space is anything but empty. The quantum foam is a seething cauldron of virtual particles, appearing and disappearing in infinitesimal instants. Particle-antiparticle pairs flash into existence and annihilate each other almost immediately, creating a constant, ephemeral background of energy that permeates the universe. These virtual particles are not just theoretical curiosities, their effects are measurable. The Casimir effect, for example, demonstrates that even empty space exerts forces due to the activity of these virtual particles. The quantum foam reveals that the vacuum is far from nothing, it is a dynamic, restless medium that forms the foundation of all physical reality. In this strange domain, the familiar rules of physics begin to break down. Classical ideas of smooth, continuous space no longer apply, and certainty gives way to probability. Fluctuations in the quantum foam can give rise to tiny variations in energy and momentum, affecting the behavior of particles that move through it. Even gravity, which shapes the structure of stars and galaxies, is influenced by this restless substrate. Some theories suggest that the quantum foam could be the key to understanding the elusive quantum nature of gravity, uniting the large-scale world of general relativity with the microscopic domain of quantum mechanics. Within the foam, spacetime itself is alive with energy. Tiny, transient wormholes or twists may form and vanish in instants, and virtual black holes could flicker briefly into existence before evaporating. These phenomena are far beyond direct observation, yet they may influence the behavior of matter and energy on scales that are just beginning to be understood. The quantum foam challenges our assumptions, suggesting that the universe is not a static backdrop but a dynamic, restless, and probabilistic foundation from which all particles and forces emerge. The implications of the quantum foam extend beyond theory. It provides a canvas upon which the laws of physics operate, shaping the behavior of subatomic particles and influencing the structure of space itself. Every electron, quark, neutrino, and photon interacts with this fluctuating background, experiencing subtle shifts and energy variations that ripple outward. The foam is, in essence, the quantum engine that drives the universe, connecting the tiniest scales to the grand cosmic architecture. Without it, particles might not exist, forces could behave differently, and the universe could be an entirely alien place. The foam is not only a stage but also a participant. Virtual particles within it mediate forces, temporarily borrowing energy from the vacuum to create interactions that allow matter to exist and processes to occur. It is a realm of paradoxes. From apparent nothingness arises energy, from fleeting instants emerges stability, and from random fluctuations emerges the structure of the cosmos. The quantum foam reminds us that reality is far stranger than our senses suggest. That beneath the solidity of the world lies a ceaseless dance of probability and energy that shapes everything we perceive. Studying the quantum foam requires imagination, mathematics, and indirect observation. While we cannot see these fluctuations directly, their fingerprints appear in the behavior of particles, the subtle energy shifts in fields, and the delicate symmetries of nature. It may hold the key to unifying the forces of the universe, to understanding dark energy, or to revealing the earliest conditions of the cosmos immediately after the Big Bang. The foam is the hidden stage upon which every particle's story unfolds, from the ephemeral mesons to the weighty top quarks. And even the ghostly neutrinos passing through every corner of existence, the quantum foam is a reminder that the universe is profoundly interconnected, that what seems empty or inert is in fact alive with activity, and that at the smallest scales, reality is dynamic, uncertain, and endlessly fascinating. Every atom, every photon, every interaction occurs against the backdrop of this restless sea of energy, and through it, the patterns of the universe emerge. To study the foam is to study the heartbeat of existence itself, the hidden pulses and vibrations that make matter, energy, and life possible. in contemplating the quantum foam, we confront the limits of human perception and understanding. Space and time are not fixed, they are fluid, probabilistic, and intertwined with the ceaseless activity of the vacuum. The foam is a reminder that the universe is far stranger and more complex than we can directly experience, yet within this complexity lies the elegance, symmetry, and interconnectedness that allow the cosmos to exist in its astonishing variety and structure. It is the ultimate theater of the invisible, the foundation of the seen, and the restless undercurrent that sustains reality itself.